Okay, so welcome to another episode of The Little Classroom That Could. In today's episode, we're going to be going through Stage 2 General Mathematics, in particular, Chapter 8C.4, Point 5 and Point 6. In this particular episode, we're going to be talking about strategies to minimise interest, but in particular, changing interest rates. So that's when you've already got a mortgage set up, and you look around and you go, oh, there's a slightly better deal where another bank is going to give me a better interest rate if I switch across to them. So thereby, we're going to decrease our interest rate, hence minimising the amount of interest we pay. This is also called, in the business, refinancing. So the trade term in the banking and borrowing industry is refinancing. So if you wanted to discuss doing this option with a bank manager or a mortgage manager, you'd walk in and say, look, I'm looking to refinance my loan. I've currently got it at 8%. I see that you're doing a deal to the public at 6%. Can I refinance that package? And then you go through your process in doing so. So we're going to run through a mathematical example of how that will look like and what the benefits would be. All right. So let's look at this question here. So Sabrina takes out a $330,000 home loan at 5.75% per annum, interest compounded fortnightly over 25 years. So compounding fortnightly, 25 years, $330,000 and 5.75%. Okay, so now that we've got all our critical information highlighted, let's start setting up what we need to insert in our calculator. So for part A, we're asked to find the minimum fortnightly repayments. So we know that these two fields here will be 26. So for 26 compounding and payment periods per year, then we know our future value is going to be 0. We're going to solve for our payment value. The present value will be $330,000. That's how much the loan is. Interest rate to start with is 5.75. The number of periods we've got is 25 times by 26. times by 25. 6 times by 25, that's 150. 2 times by 25 is 550, that's 0, 5, 6. So, total of 650 periods. So, we need to feed that information into the calculator for TDM solver. We end up with a payment value that looks like minus $957.63. It's 957.63. So find the outstanding debt after 15 years. So we know that after 15 years, that will be 15, 26 lots of that. 6 lots of 15 is 90. 2 lots of 15 is 30. That would be 390 periods we'll have gone. So 390. So from here, we just change the numbers, leave our payment the same, and we now want to solve for the future value. So I'll change the periods to 390. Remember, to get answers that are consistent with the textbook, we need to round out this last value to 63. Then solve for the final value, which will be minus 189,196.53, rounding up. So that's going to be how much money we're going to be outstanding. 189,196.53. Alright. So after 15 years, Sabrina transfers the remainder of her loan to a bank charging 5.5% per annum, interest compounded fortnightly. We need to calculate the new fortnightly repayment. So the outstanding periods we'll have will actually be 650 minus 390. Over here, that'll be 5, carry the 1. That will leave 6. 200 n as 260. I'm going to change this present value to 189,196.53. The future value changes to 0. And now we are going to solve once again for the payment. We end up with minus $946.80. So that goes in here. So the interest saved will actually just be 260, so that's the total amount of periods per year. So periods remaining times by the difference of the two sums. So that's 957.63 minus 946.80. If we go back, if we quit TVM solver, stick that into our calculator, 957.63 minus 946.80, close bracket, enter that, finally we end up with 2,815.80. So we should probably put a $sign in front of that, and there we go. Right, so the total interest saved is $2,815.80. Thank you. Okay, so now let's turn our attention to 8C.5, making lump sum payments. So here we're talking about sometime throughout the term of the loan, you might come across an extra amount of money. Let's say you get a sizable tax return one particular year. Yep, no worries, we'll dump that on our home loan. Or unfortunately, if a member of your family passes away and they leave some money to you in your will. Another thing might be, so we're going to work on an example of question 2 here, which states here that Jason takes out a home loan of $220,000 at 5.9% per annum, interest compounded monthly over 20 years. So we're asked to find the minimum monthly repayment to start with. So start from the bottom as we do. We're told that it's compounded monthly, so 12 months per year. So there we go. The final value of the loan will be 0. Asked to solve for the payment. The present value of the loan is $220,000. The interest rate here is 5.90%. Number of terms, told it's a 20-year loan, times by 12. So 20 times by 12, that's 0. So that's 2 times by 12 is 240. There we go. So let's feed all these values into TVM solver. So we end up here with minus 1563.4, well it actually says 0.48277, but we can't pay a decimal point of a cent, so we have to round up, or so we always have to go up. This term in mathematics is actually called ceiling. So we need to take the ceiling of that term. So the minimum repayment will be 1,000, I'll put just comma separator in here, $563.49. So we're next asked to find Jason's outstanding debt after 5 years. So here we have to remember that this is going to go up to the 9, and we want to know after 5 years, 5 12s are 60. We want to find now the future value. So let's set this in play. So here we end up with negative 186 469.4232. And this figure we end up rounding down. So after 5 years, the lump sum, so Jason's outstanding balance after 5 years is $186,000. So $186,469.42. There we go. So after 5 years, Jason receives $20,000 from his grandmother's will. He decides to use it as a lump sum payment towards his home loan. How much sooner will Jason repay his home loan? Alright, so what we're doing now, interest rate remains the same. The present value, we'll need to take this value here that we've used, but deduct the $20,000 he's getting from his grandmother. So that will be 166,469.42. Future value of the loan would be 0. These two values are the same. Actually, we're going to solve for the number of terms remaining. So we leave our payment in as it was. So that value is 0. As a value of 166.469. 166,469.42. 5.9, and we solve. So this is 151.137. Now you can't have a part of a month, so we're going to need to round that up. So that will be 152 months. So it'll be 180 months left to go. So 180 minus 152. 7 carry the 1. 8. 7 minus 2. 28 months sooner. 28 months sooner. And if we turn that, that will be 2 years and 4 months. So in part 2, we're asked how much interest will Jason save by making a lump sum payment. So to determine that, we have to find first what his total repayment would have been to start with. So that would be, the repayment total would equal, in this instance, 180 multiplied by the total payments, 1563.49, which equals, this is 281,428.20. So that's the repayment total that he would have done so initially. So now that we have to calculate what his actual repayments were. Okay, so the repayments actual, what he has paid on the loan, is 152 times by 1563.49. Now we also have to remember here, he's also had to make an additional total repayments, so his actual repayments, he's added another $20,000 here. So this is the total amount he's had to repay. So we can stick that in the calculator, end up with 52, and we can say plus 20, 1, 2, 3. We end up with $257,650.48. So his interest saved is just the difference of these two. I'm saying 281,428.20 minus 257,650.48. 8C.650.48, and we can stick that in the calculator. That will equal 23,000. Let's stick a dollar sign in there, sorry. Dollar sign, 23,777.72. Alright. So there we have it. In total interest saved is $23,777.72. The question that's posed is, how much interest will Jason save by making the lump sum payment? So the total interest save, or the money save that he's been doing, is he's able to be paid 28 months sooner. So we could say 28 times by a monthly repayment, minus the $20,000 here, or should I probably underline that he's been able to pay it off, because that's all it's going to cost him an amount of money. So we do that evaluation, we end up with $23,772. Now this is an alternative way that I've shown that will work for this particular scenario. That's different to the approach that's taken in the textbook. If you're posed a question like this, you can do this as a shortcut and keep that tucked up your sleeve. Just an alternative approach. Okay, so for our last question here, we're asked for 8C.6 using an offset account. So what an offset account does is it's an account that sits sort of next to your outstanding amount next to your outstanding amount for the loan in another account that you can still access, but counts against the principal that's outstanding. So the bank can holds onto it and goes, well, we'll sort of half pretend that you made this deposit, lump sum deposit against the loan, but you can take it back at any time you want. All right. So that's what an offset account is. It's sort of like having the best of both worlds with, as I discussed with earlier, making a lump sum payment. It's sort of making a lump sum payment, but then you still have access to your money again. All right. So in this instance for question 3, Fabian has taken out a loan for $180,000 over 30 years at 8.4% per annum, interest compounded monthly. His monthly repayments are $1,371.31. So for 3A here, we're asked to calculate the interest Fabian saved during the month by depositing the money in the offset account. So what I've done here is I've determined the total amount of money that's in the total amount that we started with. So it's $175,460.67. Plug that in for 1 month and using the factors that are here, determine the final value left after 1 month. This gives this value here. Then if we take $175,460.67, deduct the $42,000 from that account, which will leave us $133,460.67. Stick that into our present value, determine the final value. That final value will come out to $133,023.58. Now we add the 42 back on top to get our other to compare final value with final value. That will give us the difference. So that will be the difference between these two will be the saving for the month. There we go, it's $294. So part B, it asks us here to find the outstanding balance in the account at the end of the month. The outstanding balance, once we deposit, if we put the $42,000 in the offset account, it will just be this figure here. Alright. So how long will Fabian take to repay the month? So the way we do this is we take our interest rate, our present value, which is this here. Our payment value will leave the same. Final value we reset to 0, and we solve for the number of terms. So the number of terms we end up having is 320.96. We can't have part of a term, so this becomes 321 months. Just bump the answer, which ends up as being 26 years and 9 months. Okay, so for part D, we're asked to find the total interest Fabian will save by depositing the $42,000 in the offset account for 1 month. Alright, so thus far we are 3 years and 1 month into our loan. So 3 years is 36 plus 1, that gives us 37. Okay. So we're also, our new duration that's left is 321. That's how much longer we're going to have left for our loan. So this will give us a figure of outstanding, the total duration of our original loan with the deposit will be 7/1 is 8, 5, 358. So I'll just write that over here. So 358 is the total duration of months for allowing for our deposit of 1 month. Now, we know that originally, the original term was 360. 360 is the original term, 358 is the new duration. So we know we're going to have 2 months, a total of, to finish 2 months early. It's 2 times our payment, which is $1,371.31, which equals to $2,742.67. There we go. There's our answer.